Okay, so let's have a look at part 2 from the strong acid-base titration, the first type of titrations that we are going to take. So let's quick review our previous section before learning new concept, before diving into the weak base, strong acid titrations or anything. Let's have a look. The first review of section 1, introduction to titration curves. What's titration? Technique used to determine the unknown concentration of an acid or a base using a solution of known concentration. A titration curve is a graph of pH versus titrant. Okay. Added that helps analyze acid-base reactions. Okay, let's have a look. What is the next part? First question, at the equivalence point of titration, what happens the reaction? Amount of acid equals the amount of base. Okay, let's have a look at second. At the equivalence point, amount of acid equal to amount of base. What strong acid, strong base titration? So the strong acid, strong base titration is a neutralization reaction between a strong acid like HCl and a strong base like NaOH. This is one of the simplest titration types because both the acids and base completely dissociates. So let's see the key ideas. What are the key ideas? The key ideas is that strong acid completely ionized in the solution, meaning all H plus, meaning that all H plus is going to form ions which are available, and strong base completely dissociates, meaning all OH minus ions are free also. When mixed in the correct proportions, they neutralize each other, completely forming water and salt. Very good example of a strong acid, strong base reaction. Sodium hydroxide and HCl forms NaCl plus water. HCl provides the hydrogen ions, NaOH provides hydroxide ions, H and OH minus combine to form water. Okay. Question number 1. Why do strong acid, strong base titration result in complete neutralization? Because the acid and the base fully dissociate into ions, or because water absorbs all the extra. Because the acid and base fully dissociate, because water absorbs all the extra ions, because some molecules remain unreacted, because the acid is stronger than the base. It causes complete neutralization because of one reason, is that the acid and base fully dissociates into ions. So HCl breaks down into H plus and OH minus fully, and HCl and H plus and Cl minus. So let's write it down. The HCl brings H plus and Cl minus. The NaOH forms Na plus and OH minus. So acid and base fully dissociate into ions. There is nothing left over. So the H plus and OH minus forms water molecules. What does the titration curve look like? A strong acid-base titration produces a very steep titration curve with a sharp equivalence point. So at the beginning, I'm starting as a strong acid. So I'm very low pH here at the beginning, and then there is a very steep, it's almost a straight line, sharp equivalence point at pH 7. So at pH 7, this is the number 7 at which the titration is concluded, because the acids and base number of moles are equal, so they form a salt and water. So this is pH equal to 7. Okay, key features of the curve. The starts at very low pH. Is it 1? Is it 2? It depends on, it is a very strong acid. What's type? If the acid is strong like HCl, it will be 1 or 2 the pH. It slowly rises as the base is added, but changes are small at the beginning, so there is no big changes. It's not very abrupt, so it's not very steep. It's regular changes, very small changes, and then suddenly it becomes a very big change in the pH. So look here at the pH. Here pH is smaller, slowly increasing, then suddenly increasing from here until it reaches 7. Near the equivalence point, pH rises sharply in just a few drops. At equivalence point, pH is equal to 7, neutral solution. After equivalence, pH rises gradually due to the excess base. So having excess base, the OH minus will be more than the H plus after the equivalence point. So it's gonna make a pH which is higher than 7 for sure. After equivalence, pH rises gradually due to the excess base. Graph summary: low pH at the start, steep rise near the equivalence, and higher pH after the equivalence. Okay, now let's have a look. Strong acid base titration question number 2. What happens to the let's go back to question to the acid? What happens to the acid base titration? The result. Why do strong no, this is number 1, this is number 2. What happens to the pH as the equivalence point is strong acid base titration? He said it's become exactly equal to 7. It becomes exactly equal to 7. Depends on the concentration of the acid. No, it's always 7. Slightly above 7, no. Slightly below 7 is no. So understanding the equivalence point is the point in which the titration where moles of acids equal to moles of base. So number of moles of acid equal to number of moles of base. This means that all H plus in ions from the acid have been neutralized by OH minus from the base. Only water and neutral salt remains in the solution. So after the titration, I have only NaCl and water. I don't have any excess from the H plus nor excess from the OH minus after the equivalence point. So only water and neutral salt remain in the solution at the equivalence point. Since water is neutral, the pH exactly equals to 7. What does it mean when titration reaches the equivalence point? We said the answer is the moles of acid equal to moles of bases added, calculating pH at different points of the titration. So you remember we have 4 different points we can find the pH at them. The first one, before any base is added, only acid is present. So if you have 50 milliliters of 0.1 molar HCl before adding NaOH, so I did not add NaOH, so I'm still here. This is the volume added from the titrant from sodium hydroxide. It's still 0, and I have only 50 ml in the flask of the 0.1 molar HCl. So 0.1 molar HCl in the flask. Before adding the solution is purely acidic. Since HCl is strong, it is completely dissociated. So HCl forms H plus and Cl minus. This 0.1 is gonna form 0.1 plus 0.1. So H plus concentration is equal to 0.1 molar. So pH is equal to negative log of 0.1. That's equal to 1. So pH starts very low here in the curve. So pH starts very low in the curve because of the high concentration of the H plus ions. Sorry. Before adding NaOH to a 0.1 molar solution, what is the pH? We found that it is equal to 1 molar. So it's equal to 1 molar. Answer B1. So during the titration before equivalence, this is the second part. This is the second part. During the titration before equivalence, as NaOH is added, so still here I did not add NaOH at the beginning. It is 0.1, so the pH is equal to 1. So let's have a look and try to draw it here. The pH is equal to 1 here. So starting the curve from this point, not from the pH equal to 0. So not from pH equal to 0, pH is equal to 1. The second part during titration before equivalence, as NaOH is added, OH minus ions neutralize H plus forming water. So OH minus neutralize H plus forming water. Every OH minus I'm having, it is added to the H plus in the solution to form H2O. The pH gradually increases. So it gradually increases but still remains below 7. So what happens to H plus in the concentration as the NaOH is added? It decreases for sure. Yeah, it decreases because I'm adding OH minus, which is neutralizing it. This was the second part. The third part, at the equivalence point. What happens at the equivalence point? At the equivalence point, there is a sharp increase. All the acid has been neutralized. Moles of H plus is equal to moles of OH minus. So only neutral water and dissolved salt. So since NaCl has no effect on pH, the pH is equal to 7. So the pH is equal to 7. This is a sharp increase in the pH. So the pH reaches until it becomes 7. This is the equivalence point. So what is the pH exactly at the why it's exactly 7 at the equivalence point? Because solution becomes pure water, because NaOH cancels all HCl. There is no H plus Cl or NaOH in the solution, so there is nothing that can make the pH less than or more than 7. Because only a neutral salt and water remains. All of the above. Yes, the answer is all of the above. Okay, strong acid base titration after the equivalence point. This is the point at which excess base is present, so the solution pH starts to increase again. So pH starts to increase again and becomes more than 7. So it becomes more than 7. Because I'm adding more NaOH than necessary, the OH minus are in excess. The pH rises above 7 because the solution is now basic. To calculate the pH, if you want to find the pH at this point, you have to find the concentration of OH minus. So find the OH minus concentration. So the POH is equal to negative log of OH minus. So negative log OH minus, so pH is equal to 14 minus pH. That's very easy way to find it. So 14 minus pH. Again, if you want to find the pH after the solution become neutral, after the equivalence point, you have to find the concentration of OH minus, find the pOH by getting the negative log of OH minus, and then pH is equal to 14 minus pH. What happens to the pH after the equivalence point? It increases. So it keeps increasing as OH minus accumulates. Now, medium difficulty questions. Let me ask you, what happens if you add NaOH too quickly to the HCl? The pH will jump suddenly, or the solution will immediately turn solid. The titration will stop working. The pH will stay below 7. Of course, pH will jump suddenly near equivalence point if you add it suddenly, not gradually. Which indicator is best for a strong acid, strong base titration? We will use the bromothymol blue, which is pH between 6 and 7.6, because it changes color at pH around 7. And I know you don't understand this one, but once we explain the part of the indicators and which indicator to use, you will understand this more and more. This section explains the strong acid, strong base titration slowly with multiple difficulty levels of questions. The next step is weak acid, strong base instead of strong base like now.